This is Geometry, Unit 9. We're doing Day 3's worksheet. It's a cancer walk. This is Eva and Olivia are walking in a 3-day, 60-mile breast cancer walk through Livonia, Michigan. After the grandma was diagnosed with breast cancer, Eva starts at the starting line and walks the entire race at a constant 3 miles per hour. Olivia got stuck in traffic and arrived late. She started the race 2 hours after Eva, but walked at a constant 4 miles per hour. Let's create a table that shows the distance. Let 0 be the time when the race started. So we know that Eva had gone 0 miles at the very start of the race, hadn't begun yet. After 1 hour, she was traveling 3 miles an hour, so she had traveled 3 miles. 3 more miles and 3 more miles after each hour goes by. So at the end of 13 hours, she has traveled a total of 39 miles. Okay, Olivia, she started late. She started 2 hours late. So at 0 hours, she had gone no amount. At 1 hour, she had gone no amount. And at 2 hours, she had gone no amount. So that's when she started. So 1 hour later, she had traveled at 4 miles an hour. So at the 4th hour, she was still behind Eva. Still behind Eva. 7 hours, still behind Eva. By the 8th hour, she had caught up and was even with Eva. So at the end of her 13 hours, she had traveled 44 miles. Now we're going to create a graph that represents our value from our tables. So on one side we're going to put miles. On the other side we're going to put hours. The miles, we want to work our way up to 40 or 44 miles. Let's see how many spots we have here. We have 20 spots. So if there's 20 spots and we need to get up to 40 or 44, then we need to make each one worth 2. So if each line is worth 2, and that would be 4, this would be 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, and then 2 more would get you up to 40. And then our hours, we'll go each hour 1 by 1. Because we only really had to get up to 13. So now we'll start plotting some of our points. Eva at 0 time was at 0. At 1 hour was up at 3. 2 hours was up at 6. 3 hours up at 9. That's a little high. Didn't look like it had the same slope there. 4 was up at 12. So notice what we're doing. We're going up 1.5, up 1.5, up 1.5. So the slope is consistent. So at the end of 13 hours, we've gone 39 miles, and that's what our chart says. So we'll take our straight edge and connect that. So we have a straight line, and that's Eva. Then we're going to plot the points for Olivia. Well, Olivia didn't start until at hour 3. She had started 2 hours late. At hour 3, she had gone 4 miles. Hour 4, she had gone 8 miles. So that's kind of we're moving up 2 lines and over 1. So after 8 hours, it was exactly the same. That's what we had here. At 2 hours, she was at 0. So we'll make this one dashed, just to show it to be different. So the dashed line is Olivia. So we have Olivia and we have Eva. Label your graphs. Okay, on the next page we're going to use the graph to identify some of these answers. When did the girls meet? Well, if we look at the chart, the girls met after 8 hours. How far had they traveled? Looking at our chart, at 8 hours, they had gone 24 miles. And how do we know? Well, the chart, those values would be the same, but also on the graph, the lines intersected. So 8 and 24, you can see here at 8, they both had traveled 24 miles. And that's where the graph intersected. Right there. 24, halfway between 22 and 26. After 8 hours. Looking at the graph, how can you tell who walked fastest? The faster pace will have a larger slope. What are the y-intercepts of each girl, and what do they represent? Well, Eva, she started at 0. What do they represent? The distance she traveled before it started. So she had gone a 0 amount before the race started, which would make sense. Olivia's y-intercept, turn her graph over. Here we are at 2. We go down 4 and over 1, down 4 more and over 1. So that would be 8 down to get even with x equals 0. So Olivia's y-intercept would actually be 8, but the reason that was is that she started late. We're going to make an equation that models each girl's distance from the starting line as a function of time. So y equals, remember when we write an equation, it's y equals mx plus b. M is her slope, that's the pace that she was traveling, so 3 miles an hour for every hour. Her y-intercept was 0, so plus 0. Olivia, she was traveling at 4 miles an hour, but for you to get that line in the right spot, you would have to consider that mathematically her y-intercept would have been -8. If you're not specific on what this y-intercept is and you only focus on the slope, then Olivia's slope could be the same thing in an infinite number of spots. If it was right there at 0 also, then she would have been ahead of Eva the entire time. But that wasn't true. She started late. On our graph, it looks like it slid over sideways. But mathematically, we typically talk about that as sliding down algebraically. Alright, so for some more practice problems, find the slope of the line that passes through these given points. The slope of the line, so our slope formula is y equals, actually m equals y2 minus y1 over x2 minus x1. Anything over 0 is going to be 0 as long as the denominator isn't 0. Find the distance. Well, the distance formula is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. We take the square roots of both of them. So, b minus 0, actually, if we're doing our x's first, that would be a minus 0, b minus 0. That's going to leave us with a squared b squared. Now there's nothing we can do with that. You can't take the square root of the a squared or the b squared because of the plus. And this one, so that should have been 2a plus 2c. So now the 2a minus the 2a would cross out. I'm left with 2c quantity squared. Over here they both cross out, so I'm left with 0. When you square 2c, you get 2 times 2 is 4, and c times c is c squared. That you can take the square root of. That doesn't have a plus or a minus between two terms. We'll look at the midpoint. So we have our a plus c over 2, and we have our b plus 0 over 2. So that leaves us with a plus c over 2 and b divided by 2. That's the best we can do in simplifying that midpoint. Those are our x terms, x1 plus x2, y1 plus y2. Collect our like terms. 2c plus 2 more c gives us 4c minus 2a. So now, because the 2 can go into both terms on both sides of the minus sign, you got to be very careful here. Because it can go into both of them, that can be reduced. So that's going to be 2c minus a, and here that'll be b. So there's our midpoint.